That Rock here with Simpson Math. We're going to do some more factoring, but now we're going to deal with factoring expressions that have a common factor. So in our previous video, we learned the AC method for factoring quadratic expressions. And here I'm going to take this expression, which is not quadratic, it is cubic. And I'm going to look at it and see that it has common factor. You'll notice that 2 will divide into this. Let's see, I need to get in the screen. 2 will divide into 2, 2 will divide into 2, and 2 will divide into negative 24. Also, they all have an x, so they all can be divisible by x. X divided by x is 1. X squared divided by x is just x, just like 5 squared, which is 25, divided by 5 ends up just being 5. So if I have x squared over x, well, that's just going to be x, okay? And then x cubed divided by x will be x squared for similar reasons. So we're ready to factor the greatest common factor. This is like undistributing. When you have a polynomial and you have a monomial on the outside, you distribute it in, we're going to distribute it out. So we say take out the common factor, and by take out we mean put it outside the parenthesis. So the common factor is 2x, and I put it outside the parenthesis. And inside the parenthesis, I put what's left after I divide this out. Well, 2x cubed divided by 2x is x squared, because this times this gives me that. 2x squared divided by 2x is just x, because 2x times x is 2x squared. And then a negative 24x divided by 2x is going to be a negative 12, because 2 times 12 will give me the 24, and then that x is attached. So 2x times the negative 12 is a negative 24x. And this is called factoring the greatest common factor. And now we just factor the trinomial that remains. So in the last video, we factored trinomials like this, and I failed to mention that if there's a common factor, you should do that first. So I'm emphasizing that now. If there's a common factor, factor it out first, then attack the quadratic expression that's left. So here, if we use the AC method, 1 times 12, A is 1, C is 12, 1 times 12 is 12, and we're looking for factors of 12. Because C is negative, we're looking for factors of 12 whose difference is 1. Well, 3 times 4 gives me 12, and their difference is 1. So I can rewrite this as negative 4x plus 3x, and negative and a positive will subtract, and you take the sign of the bigger one, so that gives me the negative x minus 12. And so inside here, we could factor out, let me open a bracket here. I can factor out an x, looking at just those two. And looking at just these two, I can take out a 3. You always bring this sign down. Take out a 3, that gives me x minus 4. Oh, look, we have this common factor here. This is in common with that, so I can factor that out. I can drop this bracket now or keep it, but I'm factoring out this x minus 4. X minus 4 goes into this x times, and x minus 4 goes into that 3 times, and there is the factorization of the cubic expression that we started with. So let's do one more example. Let's say I have 5x to the 4 minus let's see, let's go with 45x squared. Okay, well, the common factor here is going to be the largest x that I see, the largest powered x, so x squared, and then obviously 5 goes into any number that ends in 5, so I can take out a 5. Well, 5x to the 4 divide, whoa, Why did I write a 5 there? That was weird. Oh, it was a 2, wasn't it? Oh, I was thinking ahead to the 5. Sorry, my bad. This is the largest powered x, so x squared. Now, what goes here? Well, one way you can think of that is you're taking this 5x to the 4, and you're dividing it by 5x squared. That's what the common factor is. The 5's always obviously knock off, and then x to the 4 is the same thing as x squared times x squared. Those knock off, so you're left with an x squared. Doing that same trick here, 5 goes into 45 9 times, and the x squareds cancel. Now, I haven't made a video over this yet, but this is a very special product. A very special product. In our little AC method, it's not needed here. And so I'll just go ahead and teach it now. Whenever the middle term is missing, whenever your b is 0, okay, in a quadratic expression, then you can factor what's called the difference of squares. So you take the square root of this term, put it here and here, the square root of that term, put it here and here. You make one plus and you make one minus. Let's check our work to see that that worked. Notice, if I take x and positive 3 and x and negative 3, and I use our little box method for multiplication, x times x is x squared, x times a negative 3 is a negative 3x, but positive 3 times x is a positive 3x, and notice those are going to add to 0, so they go away, and then 3 times a negative 3 is a negative 9, and so the only terms I have left are x squared minus 9, so yes, x plus 3 times x minus 3 is equal to x squared minus 9. This is called the difference of squares rule. I'll make another video on it later, but there we have the factorization. So the key thing that I want to point out is what I started with doing was taking out the common factor. I looked for something that was common and I factored it out first. Then I dealt with the quadratic expression. Math made simple, Simpson math.